Alright, welcome to this other video, guys. We are solving more example of linearly independent systems. So as we saw in the previous video, that this function t of y is a linear homogeneous differential equation, okay? So of order n. Now if we consider this function t of y equals 0, then we have the following. The dimension of the solution space is n for this n order polynomial, and secondly, any linearly independent set given by this capital F of a solution to ty is a basic, and any solution can be written in this form. Okay, so we have the basic, we have the general form of the solution given here. Okay, and the dimensions of the solution space is just n in this case. So you know your basics, you know the dimension. Okay, let's look at this example. Example 1. You are giving this set 1 e to the power x squared over 2, and you are also giving this equation, second order differential equation, x minus x squared plus 1 times y is equal 0. The first question here is to show that this set is a basic to this equation, and secondly, we have to find the general solution to this equation. Okay, we want to show that this set is a basic to the solution space of this equation. Okay, so let's call this y1 is 1 and y2 is given by the second set here. This is x squared over 2. So y1 prime is 0 and y1 second derivative is also 0. So y2 for the first derivative is x times e to the power x squared over 2, and the second derivative is e to the power x squared over 2 plus x squared times e to the power x squared over 2. Alright, if we substitute then the first one, if you take this first y1, we substitute here, we have 0 minus 0 is equal to 0, so this satisfies. For the second one, y2, so this is x times y prime 2 minus x squared plus 1 y prime is equal to 0. So if we substitute this, let's continue here and see. This is x times e to the power x squared over 2 plus x times e to the power x squared over 2 minus x squared plus 1 times the first derivative is x times e to the power x squared over 2. So if we expand this, you see that we have x to the power 3 here, and here we will also expand and obtain x to the power 3. And the second one is x to the power 1, and here we also have x to the power 1. So this gives us 0. We conclude that this set is a basic for the solution space of this differential equation. Then y1 and y2 are solution to this differential equation. So the general solution here, if you write yj, general solution is a plus b times e to the power x squared over 2 with a and b in R. Okay, so this is the general solution. Now I want to check whether this set is linearly dependent or not. We want to use the Wronskian. The Wronskian method says that we have to use write the first function, derivative of the first function. Here is e to the power x squared over 2, and the derivative is x times e to the power x squared over 2. So if we cross multiply this, we obtain x times e to the power x squared over 2. Okay, this is the Wronskian. If we give a value to x, let's say 1, if x is equal 1, the Wronskian of 1 is different from 0, because if you substitute here, you have exactly e, okay, and that's different from 0. Conclusion, 1 e to the power x squared over 2 is linearly independent. Alright, for the second example, we are giving this equation. The second derivative of y plus y is equal to 0. First question here is to show that y1 and y2 satisfy this differential equation. And secondly, we want to show that y1 and y2 is a linear independent set. Okay, so let's start, and obviously we can write the general solution of this differential equation. Starting with the first question, we find the first derivative. Y1 is equal cos this. First derivative of this is sine, and the second derivative should be minus cos x. Y2 is equal sine x. The first derivative is minus cos, and the second derivative is minus sine x. Then, if you substitute in this equation, you have y1 prime plus y2 plus y1 is equal 0. This is minus cos x plus cos x is equal 0. Alright, we do the same for y2. You substitute by sine, you have minus sine plus sine is equal 0. Conclusion, y1 and y2 satisfy the differential equation given by this. Okay, now let's move to the second part. The second part is to show that the system is linearly independent. So we find the Wronskian here is y1 is cos x, y1 prime is sine x, and y2 is sine x, and y2 prime is minus cos x. So if you cross multiply, then we have cos square minus, so this is minus cos square minus sine square. This is equal minus 1. So this is different from 0. Okay, and the conclusion is that this set y1 y2 is independent, is linearly independent. Now if you have to write a general solution, it's just a combination of this y1 and y2. So the general solution, y general is a cos x plus b sine x. Alright, this is all for this video. So these two examples, the application, direct applications of this theorem. So I hope it is understandable. I look forward to seeing you in the next video. Thank you.